Here we have a problem on quadratic equation. Okay, let's go with the question. If L positive, M positive, N equals to 0 and L, M, N are rationals, then the roots of the equation M positive, N negative L times X square positive, N positive, L negative M times X, L positive, M negative N equals to 0 are. Okay, here we have a quadratic equation, and so we have to identify what type of roots do we have for this quadratic equation. That is, we have to find the nature of the roots, whether the roots are real or imaginary, rational, irrational. So because when I go over the answer choices here, answer choice A says the roots of this quadratic equation are real and irrational, B says real and rational, C says imaginary and equal, and answer choice D says real and equal. Okay, whenever I want to find the nature of the roots of a quadratic equation, first we have to make sure the given quadratic equation has to be in standard form. That is, it has to be in the form of ax square positive bx positive c is equal to 0. That is, we must have all the terms on one side of the equation, on the other side we must have 0. And to get the nature of the roots, that is to identify the types of the roots of the quadratic equation, we have to find the value of the discriminant, that is b square negative 4ac. So based on the value of this discriminant b square negative 4ac, we will decide whether the roots of the given quadratic equation are real and irrational, real and rational, imaginary, or real and equal. Okay, now first let me write the required stuff for that. Here I have written the stuff. Let me consider the first point we have over here. So there is a value of the discriminant b square into 4ac is greater than 0, and also it's a perfect square. Then we have to decide the roots of this quadratic equation are real and rational. In case the value of this discriminant b square into 4ac is greater than 0 but not a perfect square, then the roots are real but irrational. If the value of this discriminant b square into 4ac equals to 0, roots are real and equal. If the value of the discriminant b square into 4ac is less than 0, that is negative, then the roots are imaginary. Okay, now what we have to do is we have to find the value of this discriminant b square into 4ac for this quadratic equation. Okay, let me continue this on the next page. Here we have the given quadratic equation. It is in the form of ax square positive bx positive c equals to 0. Okay, in that case we have b equals to m positive l negative m, and for a the coefficient of x square m positive n negative l, and c is a constant term, that is l positive m negative n equals to 0. Okay, now let's find the value of the discriminant b square negative 4ac, that is equal to, so here already we have discussed that b is the coefficient of x, so coefficient of x in our quadratic equation is n positive l negative m the whole square negative 4 times a is the coefficient of x square, that is m positive n negative l times c is a constant term, that is l positive m negative n. Okay, now we have to evaluate the expression over here. For that, let me consider an information in the question, that is we have the value of the expression L positive M positive N, that is equal to 0. Let me take this piece of information, that is L positive M positive N equals to 0. Okay, now what I am going to do is I am going to subtract L from both sides of this equation. If I subtract L from both sides of this equation, then I will be getting m positive n equals to negative L. Okay, if I subtract m from both sides of this equation, then I am getting L positive n equals to negative m. Okay, if I subtract n from both sides of this equation, I will be getting L positive m equals to negative n. Okay, now let me consider the first term over here, that is n positive L negative m whole square. So we got that n positive L equals to negative m. So we can plug in negative m for this n positive L over here. Then I'm getting negative m the whole square, negative 4 times. Okay, here we can consider the first equation over here, that is m positive n is equal to negative L. So we can plug in this negative L for this m positive L, then I'm getting negative L. And here we can consider the third one over here, that is L positive m equals to negative n. So we can plug in this negative n for this L positive m, then I'm getting negative n. Okay, so here negative m, when I combine them, I'm getting negative 2m the whole square, negative 4 times. So here when I combine negative L and negative L, I'm getting negative 2L, and here I'm getting negative 2n. Let me write over here. Okay, here since we have even exponent over here, the negative sign inside the parenthesis will become positive. So we can write this one as 2m the whole square, and here we can multiply this negative and negative, it will become positive. When I multiply this positive and negative, I am getting negative. That is, when I multiply these three negative signs, I am getting negative sign as a result. Now when I multiply this 4 times 2, 8 times 2 is 16. Then when we multiply this L and N, I am getting 16 Ln. Here we have 2 and m are multiplied, and we have the exponent 2 in common. So whenever two terms are multiplied and we have the exponent in common, the exponent can be taken separately for each term and multiply the result. When I take this exponent 2 for this 2, it will become 2 square. 2 square is just 4. And when I take this exponent 2 for this m, I am getting 4m square negative 16 times L times n. Okay, here both 4m square and 16 ln are the multiples of 4. So we can factor 4 out. If I factor 4 out, then I am getting m square left in the first term. So in this 16, 4 is factored. We just have 4. That is, we have 4 ln over here. Okay, let me continue over here. Then we get 4 times, instead of m square, I am writing negative m the whole square over here. Because whether I write m square or negative m the whole square, both of them are equal. Since we have even exponent over here, the negative sign inside the parenthesis will become positive. So it's still equal to m square. And here we have a question. Why do we have to write this m square as negative m the whole square? Because here I know some stuff for negative m. That is L positive n equals to negative m. So when I have, instead of m, when I have negative m over here, for this negative m, I can plug in this L positive m. That's the reason I'm writing m square as negative m the whole square. I am writing this one as it is. That is negative 4ln. Okay, now 4 times. Now for this negative m, we can plug in this L positive n. Then I'm getting L positive n the whole square negative 4ln. Now we have 4 times. We can expand the square of the binomial over here using the algebraic identity, that is a positive b the whole square equals to a square positive 2ab positive b square. So here comparing this and this, at the place of a we have L, at the place of b we have n. So in this expansion on the right side, at the place of a we have to write L, and at the place of b we have to write n. Okay, let me do it. Then we get L square positive 2ab, that means 2 times L times n, positive b square, that is n square negative 4ln. Okay, then we have 4 times here L square. We can combine this positive 2ln and negative 4ln. When I combine them, I am getting negative 2ln positive n square. Okay, now let me continue on the next page. This is the last step we have had on the previous page. Okay, now let me consider the quadratic expression we have inside the square bracket. It's exactly in the form a square negative 2ab positive b square. Okay, whenever we have a trinomial in this form, it can be written as a square of a binomial, that is a negative b the whole square. Actually, it is an algebraic identity. Since the trinomial we have over here is exactly in this form, so the trinomial L square negative 2 times L times n positive n square can be written as a square of the binomial. So okay, now let me write it 4 times. Since we have L at the place of a, so in the square of binomial over here, at the place of a we have to write L, and we have n at the place of b, so we have to write n at the place of b over here. Then this trinomial can be written as a square of a binomial, that is L negative n the whole square. Okay, now actually this 4 is a power of 2. There is a 4. This 4 can be written as 2 square times L negative n the whole square. Okay, here we have a product of 2 terms, and both the terms are having the same exponent. Whenever we have a product of 2 or more terms with the same exponent, what we can do is we can multiply the bases and take the exponent in common. In that case, I'm getting 2 times L negative n the whole square. Actually, we get this result for the discriminant of the quadratic equation b square negative 4ac. So the b square negative 4ac equals to 2 times L negative n the whole square. Actually, the question says L, M, N are rationals, and here so L negative n. When we subtract 2 rational numbers, so this one also will be a rational number, and so this is multiplied by 2, and for the complete stuff we have the exponent 2. Okay, here it doesn't matter L is greater or N is greater, even if this one becomes negative because of the even exponent over here. So this is this value will be positive, that is greater than 0. And also we have square over here, it is a perfect square. So clearly the value of the b square negative 4ac is greater than 0. This is positive because of the square, and also since we have square over here, this is a perfect square. B square negative 4ac is greater than 0 and also a perfect square. Let me write the stuff over here, perfect square. So when the discriminant is greater than 0, that is positive and also a perfect square, what do we have to conclude about the roots of the given quadratic equation? Let me go to the previous page. Okay, here we got the result b square into 4ac is greater than 0, and also the value of this b square into 4ac is a perfect square. Then the result is roots are real and rational. That means the roots of the given quadratic equation are real and rational. We find this stuff exactly in answer choice B, real and rational. The correct answer choice for this question is B.